So section 4.5 is all about dividing polynomials. If you skipped this section before this, which was a review of long division, I do suggest you go back and watch that. This is a concept we really need to have down solid. We're going to see it as we move through this course, especially in chapter 11, which I know feels like a long way away. It'll be here sooner than we know it. So first I want to discuss dividing a polynomial by a monomial. So to divide a polynomial by a monomial, what we want to do is divide each term of the, wow, typo of the year, the polynomial by the monomial, and then write each quotient in its lowest terms, i.e. simplify all fractions. So what are the steps? So first, we're going to write them as separate fractions, so we're pulling them apart, and then we're going to divide the coefficients and simplify the exponents. So why don't we look at this example I have typed up for us. So I have f of x divided by g of x, where f of x is 15x cubed plus 9x squared, and g of x is 3x squared. So how would I simplify that? So I could pull that apart. I could write that as 15x cubed over 3x squared plus 9x squared over 3x squared. Note that if I went ahead and added these two fractions, I'd get back to what we had originally before. Now I'm going to divide the coefficients. So let's look at this first term here. 15 divided by 3 is 5. X cubed divided by x squared, we're going to use our quotient rule, that leaves me with x. If I have 9 divided by 3, that's 3. X squared divided by x squared is 1, so I have 5x plus 3. Let's work through some examples as a group. As a group, you aren't here. You're on the internet. That's great, though. Way good for you. Okay, so next example. I have 15x squared plus 20x minus 5. So my first step is going to be pull this apart. So I have, let's change colors, 15x squared over 5 plus 20x over 5 minus 5 over 5. And then I simplify each of these terms. 15 divided by 5 is 3. There's no x term in my denominator, so I get 3x squared plus 20x divided by 5, that's 4x squared, minus 5 divided by 5, which is 1. Let's do another example with variables in the denominator. So I have negative 12x to the 8th plus 4x to the 6th minus 8x cubed divided by 4x squared. So that's going to be negative 12x to the 8th plus 4x to the 6th minus 8x cubed divided by 4x squared. So let's pull that apart. So I have negative 12x to the 8th over 4x squared plus 4x to the 6th over 4x squared minus 8x cubed over 4x squared. And again, I just want to note that if I went ahead and added and subtracted these fractions that I pulled apart, I'd get back to what we had originally. That's one of the reasons why this works. So now I need to simplify each term by dividing the coefficients and then simplifying the variables. So I have negative 12x to the 8th over 4x squared. Negative 12 divided by 4 is negative 3. X to the 8th divided by x squared is x to the 6th. If I have 4x to the 6th divided by 4x squared, my 4's cancel, so I'm left with 1. That's a coefficient. We don't write 1 as a coefficient, remember. If I've got x to the 6th divided by x squared, that's x to the 4th minus 8 x cubed over 4x squared. 8 divided by 4 is 2. X cubed divided by x squared is x. So there's our fully simplified polynomial divided by a monomial. One more example with multiple variables. Ooh, exciting. So I have 8xy squared over x squared y squared. Again, we do the same thing where we pull this apart. Minus 9x squared y over x squared y squared plus 6x squared y squared over x squared y squared. So now we've got two variables to worry about. Luckily, our leading coefficient is 1. So I'm going to have 8. If I have x divided by x squared, That would give me x to the negative 1, so I have an x in my denominator, and my y's cancel. Minus 9, my x squareds cancel. I've got a y in the numerator, but 2 in the denominator, so I have a y in my denominator. Plus 6, I've got my x squareds and my y squareds that cancel. So I have 8 over x minus the quotient of 9 over y plus 6 is my final answer.